All right, there's a lot here. I'm going to try my best to be speedy. Okay, so we're going to do bases other than E for differentiation and integration. So first off, let A be a positive real number and let U be a differential function of X. So if I want to take the derivative of something to the U, what we're going to do is it's going to stay A to the U, but we need to multiply that by the ln of the base. And I'll put it in parentheses. If we take the derivative with respect to X and I have an input of U, we need to multiply by the chain of U prime. Okay. So same is true for log is pretty similar. So if I have the log of U base A of U, we're going to have, like ln of U is 1 over U. Okay, so it's going to be the same. It's going to be 1 over U times U prime. But then we need to multiply by a constant of 1 over the ln of A. And we're going to do the proof right now. Okay, so for the base other than A, so what I know is that A to the U is equal to E to the ln of A to the U power. These are the same, okay? So what I get here is that this is E. If I move the U to the front, then this is U times the ln of A. And the ln of A is just a constant, and U is our, is the function that or the variable that we're taking the derivative of. So I now have, if I have the function E to the U times the ln of A, and I want to take the derivative of that, remember that's just A to the U, rewritten in a different way. Okay, so I'm going to take dx of this. Now, what I am saying is that this is equal to E to the U times ln of A times, okay, so because it's E to the U to the ln of A, so it's equal to itself times the derivative of the inside. Okay, remember that the inside ln of A is just a constant, so it's times ln of A times the derivative of U is du dx. Yeah? So we get that E to the ln of A to, oops, I wrote that right. ln of A to the U times ln of A times du dx. So we just rewrote this part with the variable or the exponent of U is equal to, okay, isn't this just equal to A to the U, right? Back in the very beginning here, A to the U times the ln of A times du dx. Ta-da! Okay, so here's the proof for the log. Okay, so we're going to start with the log base A of any value is equal to U. Okay, and I remember from pre-calc that I can use change of base. So I'm going to say that instead of log base A, I'm going to change this to the ln of U over the ln of A using change of base. Okay, so I can split this up as 1 over the ln of A times the ln of U, just so it looks a little different. Remember this part? That's just a constant, right? It's just a scalar. So I have dx of 1 over the ln of A times the ln of U. Okay, so the derivative of ln U is 1 over U times du dx, and then I need to multiply any derivative by its scalar. so the ln of a. And so we see that the log base a of u is just equal to 1 over ln of a times 1 over u times du dx. That's the proof. Now you can memorize it. Okay, so let's do a couple of examples. So I have d dx of 5 to the x, and I really don't expect you to make the proof every time. So what I need to remember is that the d dx of a to the x is equal to the ln of a times a to the u times du dx. Okay, my u is x, so the derivative of x is just going to be 1. Okay, here we go. So I have a is 5. So I have the ln of 5 times a to the x times the derivative of x, which is 1. So I get the ln of 5 times 5 to the x. This should be a 5, not a. Okay? All right, number 2. d dx of 2 to the 3x. So I can see that my 2 is my a, my u is my 3x. So I have the ln of 2 times what's there. So 2 to the 3x times the chain of 3x, which is 3. Okay, so I can rewrite this as 3 ln of 2 times 2 to the 3x. I didn't box my last answer. All right, next one. So let's write the equation of a tangent line to y is equal to x squared times 4 to the x at x is equal to 1. Okay, so we need to find the derivative. So y prime is equal to left, so x squared, d right. So the derivative of the right would be my a is equal to 4 and my u is equal to x. So I get the ln of 4 times 4 to the x times the derivative of x is 1. Okay, plus the right d left, so 4 to the x times 2x. Okie doke. Now we're going to, you know what, all of this here, I'm going to put a set of parentheses. And since the product rule, all of that is multiplied by, right? No. I had it right the first time. Okay, so I have y prime of 1 now. I'm not going to simplify it because it just seems easier to plug in 1 right now. I have 1 squared times the ln of 4 times 4 to the 1 plus 4 to the 1 times 2. So I get y prime of 1 is equal to 4 ln 4 plus 8. Okay, so that is the slope at at x equals 1. So now let's figure out the point. So y of 1 is equal to 1 squared times 4 to the 1, which is 4. So I go through the point 1 comma 4. So y minus 4 is equal to the slope 4 ln 4 minus 8. Yes, plus 8. Okay, from up here. Times x minus 1 in point slope form. That's it. Let's do number 4. Okay, so find the second derivative of 3 to the x. All right, so we have f of x. So 3 is not a base of e. My base a is equal to 3. and my u is equal to x. So I have dx of 3 to the x is equal to, actually, let's write it like this. Let's do f prime of x is equal to the ln of 3 times 3 to the x times the derivative of x, which is 1. So the ddx, or f prime of x, is equal to the ln of 3 times 3 to the x. Now we're going to take the second derivative, so f double prime of x. So ln of 3 is just a constant, so I'm going to write it out front, times, and now I'm going to take the derivative of 3 to the x again, which is the ln of 3 times 3 to the x times 1, same as before. So I get f double prime of x is equal to 2, no, let's try that again, is ln of 3 squared times 3 to the x. All right, number 5. Differentiate log of cosine x. All right, so I'm pretty sure I can take the derivative of log of u, log base 10 of u, okay? Remember, there's an invisible 10 here. So my a value is going to be equal to my base, and my u is equal to cosine of x, okay? So I have that y prime is equal to 1 over the ln of the base, which is 10, okay, times 1 over u, which is cosine of x, times the derivative of cosine x, which is negative sine x. So again, y prime is equal to 1 over ln a times 1 over u times u prime. I should have written that first. Oh well. Okay, let's do one more. Same. We have y prime is equal to 1 over the ln of a times 1 over u times u prime. So a is equal to the base, and u is equal to the input, so 3x. So I have y prime is equal to 1 over ln 5 times 1 over 3x times the derivative of 3x, which is 3. Okay. Well, I have no idea how that got filled in or how it became a rectangle-ish. It's not quite a rectangle. Quadrilateral. Okay, so we're going to take the integral of bases other than e. So now I have the antiderivative of a to the u du is equal to, it's really similar, okay? So I get, when I take the antiderivative of e to the u, it's e to the u. It's the same deal here, except for it's a to the u times 1 over the ln of a plus c, okay? And let's do a little proofy proof. Okay, so I have a to the u is equal to e to the ln of a to the u, which can be rewritten as e to the u times the ln of a. Okay, so we're going to use that because we know how to take the antiderivative of e to the u. Okay, remember that ln of a is just a scalar. It's just like a number that we're multiplying by, that it's a constant. We already know what number it is. Okay, so I have the antiderivative of e to the u times the ln of a du. All right, so I'm going to make, since I already used u, I'm going to make my exponent v. So so the v is equal to ln of a to the u. So dv is equal to ln of a times u prime, which is du. All right, so I get du is equal to dv over the ln of a. Let's do some substitution. So I get e to the v dv over the ln of a. And I can rewrite that as 1 over the ln of a, since this is just a number, since a is a parameter and not a variable. Okay, e to the v dv. So I just bring down my 1 over ln a times e to the v plus c. So rewrite 1 over ln a times e to the ln a times u plus c, which then I remember that ln a to the u is the same thing as a to the u. So this is equal to 1 over ln a times a to the u plus c. Okay, again, I don't expect you to come up with these proofs. What I need you to do is remember the rules, but this is how we get them, okay? Okay, so we're going to take the antiderivative of 2 to the x. So again, the base value is a, okay? And my u is equal to x. So I get the antiderivative of 2 to the x. Since my u is just x, I can just take the antiderivative. It's nice that way. So I get 1 over ln of a times a to the x plus c. So it's 1 over ln 2 times 2 to the x plus c. All right, next one. Little trickier here, but again, we kind of know how to take the antiderivative of 5 to the u. So let's try and make negative x squared equal to u. So du is equal to negative 2x dx. So dx is equal to du over negative 2x. Okay, now let's see what we got. We got x times e to the u du over negative 2x. And the x's cancel, leaving me with 1 over negative 2 times the antiderivative of e to the u du. I fully recognize you can probably skip some of these steps. So I get 1 over negative 2 e to the u plus c, and I'm just going to bring my negative out, replace my u with negative x squared plus c. Wait a second. I missed something. Ha! I see what I did. Okay, let's try this one again. Okay. All right. So I have x times 5 to the u du over negative 2 x. So I'm going to cancel, giving me negative 1/2 times the integral of 5u du. Okay. So the antiderivative of 5u is 1/2 times the ln of 5 times 5u plus c. Okay, so I get negative 1/2 times the ln of 5 times 5 to the negative x squared plus c. Okay, so that is, oh wait, this is 1 over ln 5. Sorry, so I can write this a little nicer. This is negative 1 over 2 ln 5 times 5 to the negative x squared plus c, or maybe you can write this as negative 1 over 2 ln 5 times 5 to the positive x squared plus c. All of these are legal. Well, they're all legal, really, but yeah. Okay, so number 3, and we're almost done here. Okay, so I have a definite integral, 3 to the x, so I can go ahead and just take the integral. So I get 1 over the ln of the base, which is 3, times 3 to the x, evaluated from 2 to negative 1. All right, so I'm just going to plug it in. 1 over ln 3 times 3 to the 2 minus 1 over the ln of 3 times 3 to the negative 1. So I'm going to simplify. I get 9 over the ln of 3 minus 3 to the negative 1 is going to go to the denominator. So 1 over 3 ln of 3. Let's get a common denominator. So I get 27 over 3 ln 3 minus 1 over 3 ln 3 is 26 over 3 ln 3. Look, we simplified fractions without a calculator. Fancy that. Okay, last couple problems here. I know this is a long one, sorry. Okay, so we have exponential functions with function bases. These are fun. Well, I think they're fun. When you have a function that is raised to a power, use an ln, because the properties of logarithms say that we can use power rule to pull exponents out of the power. So if I want to take the derivative of y equals x squared, I'm going to take the ln of both sides. Oops, not x squared. It's x to the x. These are cool. So excited. Okay, so I have x to the x. So what I'm going to do is use the power property to move the power to the front. So x ln x. And then now we're going to take the derivative of both sides, d dx. So the derivative of ln y is 1 over y. And then don't forget to tack on your chain of dy dx. And that is equal to, we're going to use the product rule. So left times the derivative of ln x is 1 over x, plus the right, which is ln x, times the derivative of the left, which is 1. All right. Now we just solve for dy dx. So I get, multiply both sides by y. I like to multiply it in the front. Okay. So I get dy dx is equal to y times 1 plus the ln of x. And then for the last step, we're just going to replace y with x to the x. So dy dx is equal to x to the x times 1 plus the ln of x. Ta-da! Last example for realsies. Okay, so find the equation of the tangent line, and I have the equation y is equal to sine of x raised to the cosine x, and we're going to find the tangent line at pi over 2. Okay, doke. So I'm going to take the ln of both sides because I see I have this power to a power, or I have a function to a function actually. Okay, so I get the ln of y is equal to the cosine of x times the ln of sine x. Then we're going to take the derivative of this, so d dx. So the derivative of ln y is 1 over y, dy dx is equal to, and then we have lefty right, righty left. So the left is cosine of x, and then the derivative of the right would be 1 over the sine of x times the derivative of sine x, the inside, okay, which is, so this is chain rule, outside, inside. The derivative of sine x is cosine x plus left, the ln of sine x times the derivative of cosine x again, or cosine x, which is negative sine x. Okay. Then let's simplify. So I get 1 over y times dy dx is equal to cosine squared. So cosine times cosine over sine x minus sine x times the ln of sine x. Okay. And lastly, we need to get y dy dx by itself. So let's go ahead and multiply y by both sides. So I get dy dx, and then let's substitute in y. So we know that y is equal to sine x raised to the cosine x. So I have sine x raised to the cosine x times cosine squared x over sine x minus sine x ln sine x, and that's the derivative. Now we're going to take that thing and differentiate and evaluate it at pi over 2. So we're going to do dy to get the slope. dy dx evaluated at x is equal to pi over 2. So we start plugging this business in. Sine of pi over 2 raised to the cosine of pi over 2. Okay, and then times the cosine squared of pi over 2 over the sine of pi over 2 minus sine pi over 2 times the ln of sine of pi over 2. Okay, and I just remember at pi over 2, the ordered pair is 0, 1. So cosine of pi over 2 would be 0, and the sine of pi over 2 would be 1. So anything that is a cosine is going to turn into a 0. Anything that is a sine is going to turn into a 1. Okay, so I get dy dx evaluated at x is equal to pi over 2 is equal to 1 to the 0 times 0 over 1 minus 1 times the ln of 1. And for the last bit, the ln of 1 is equal to 0, right? So I get a big fat 0. Okay, since 0 minus 0 gives me 0, anything times 0 is 0, this is going to equal 0. That was super anticlimactic. Okay, anyway, the last thing we need to do is find the point. So I'm going to evaluate y of pi over 2, and y is sine x over, or sine x to the cosine x. So sine of x to the cosine x, which is sine of pi over 2 to the cosine pi over 2. Cosine is 0, sine is 1, so this is 1 to the 0, which is equal to 1. So the graph goes to the point pi over 2, 1, and has a slope of 0. So y minus y1 is equal to m times x minus x1. So y minus 1 is equal to 0 times x minus pi over 2. This is a lot of work to get that y minus 1 is equal to 0 and y is equal to 1. The tangent line is horizontal. That's it. All right. That's